Hello everyone, welcome to another video. Let's solve this challenge physics question on the board. A truck starts from rest. Its acceleration up to its maximum speed is given by A, that is acceleration equals to parenthesis P minus QT raised to the nth power, where P, Q, and N are constant. Express the maximum speed in terms of P, Q, and N. Okay, so the truck starts from rest. Let's take it from there. The truck starts from rest, and that means the initial speed of the truck, okay, will be equals to 0. All right, so initial speed of truck, and that's letter U, that's equals to 0. Okay, now its acceleration up to its maximum speed is given by A equals to parenthesis P minus QT raised to the nth power. So which means what I would need to do first is to find the time duration from the start or from rest, okay, from rest up to the maximum speed of the truck. Okay, so to calculate the time, okay, it means that I'll need to consider the fact that when the truck reaches its maximum speed, the acceleration will be equals to 0. So which means at maximum speed, okay, at maximum speed, acceleration will be equals to 0. So which means when A is equals to 0, so let's not forget that we have A, we are giving A, rather, let me write it here, giving A to be equals to parenthesis P minus QT raised to the nth. Okay, so now when A is equals to 0, so this will be 0 equals to parenthesis P minus QT raised to the power of n. All right, so then in this case, I'm going to get rid of power n, and to do that, I'm going to raise both sides, okay, to the power of 1 over n. That means I'm going to multiply this power by 1 over n. So now let me raise both sides to the power of 1 over n. So which means this will be 0. Why this will be parenthesis P minus QT raised to the nth times 1 over n. Okay, so this will be P minus Q equals to 0 because n multiplied by 1 over n, that will be 1. So that P will be equals to QT. Then T will be equals to P over Q. So which means the time duration from the origin or from rest, okay, up to the maximum speed of the truck is T equals to P over Q. Okay, so this is the time duration from rest, okay, up to the maximum speed, okay, of the moving truck, So that's it. So now again, because velocity can be expressed as the integral of acceleration with respect to time, let's not forget that our task is to express the maximum speed in terms of P, Q, and N. So when I say velocity, it also means speed, okay, in this case. All right, so now because we have that velocity, that's V, is equals to the integral of acceleration, okay, with respect to time t. So which means velocity will be equals to integral of A dt, okay, then plus the constant of integration. We want to write an expression for the maximum speed in terms of P, Q, and N. So, and because velocity can be expressed as the integral of acceleration with respect to time t, okay, so, and this is the mathematical, that's a mathematical expression. So now, from here, we know that A is equals to this. So that means that V will be equals to the integral of parentheses p minus qt raised to the nth power with respect to t plus constant of integration. Okay, so now to integrate this, okay, I'm going to use method of substitution. Okay, and to use method of substitution, let's not forget that one of the general rule of integration, let's consider the general rule for integration. One of them is that if you have, let's say, integral of x raised to the nth power with respect to x, this will be x raised to the power of n plus 1 over n plus 1 plus constant of integration. But because we have an algebraic, expression that is p minus q, that's within the parentheses. So I can use this one. Let me use this one, ax plus b. Yeah, let me use this one. This will be equals to ax plus b raised to the n plus 1 over n plus 1 plus the constant of integration. Now, then this will be multiplied by 1 over a. Yes. So where a in this case, okay, a in this case, let me not use a, but a in this case is our minus q, okay, because we are integrating with respect to t. So in this case, this will be v equals to minus 1 over q using method of substitution. That is, if I let p minus qt to be equals to u, so that means that du over dt will be equals to minus q. So which implies that dt will be equals to minus 1 over q times du. Okay, that's it. All right, so which means that this will now be multiplied by, when we integrate this, that will be parentheses p minus qt raised to the power of n plus 1 over n plus 1 plus the constant of integration. Okay, so what to do now is to find the value of c, that is the constant of integration. So the constant of integration is when we have v to be equals to 0 and time t equals to 1. 0, that is when we consider the initial value conditions. So when we set v equals to 0, then time t will be equals to 0, and that will be this is going to be 0 equals to minus 1 over q, okay, parentheses p minus, this will be 0 raised to the power of n plus 1, okay, divided by n plus 1, then plus c, okay, so that this will be 0 equals to p minus p over q minus, now this will be minus p raised to the power of n plus 1 over q multiplied by n plus 1, then plus c, so that c will be equals to p raised to the power of n plus 1 divided by q parentheses n plus 1. So this is our integration constant. So which means the velocity function will now be velocity or speed function, because we want to calculate the maximum speed. So speed function, that is v of t, that is v as a function of time t, that will now be, so I'm going to put this back into this equation, so that we are going to have minus 1 over q parentheses p minus qt raised to the power of n plus 1 divided by n plus 1, then plus c, which is p raised to the power of n plus 1 over q parentheses n plus 1. So that is the velocity function. That's the velocity function. Now, to write the expression for maximum speed, okay, in terms of p, q, and n, so it means that I'm going to substitute the value of that t, okay, that is the time duration from rest up to the maximum speed of the moving truck. Okay, so let me continue from here. Now, to write an expression, for the maximum speed, to write an expression for the maximum speed. So now we have that t is equals to p over q, which is the time duration from rest, okay, up to the maximum speed. So I'm going to substitute that into the equation. So maximum speed, okay, is at t equals to p over q. So which means that the maximum speed will be equals to, so this is minus 1 over q, okay, then in that case we have p minus q multiplied by p over q, which is t, okay, raised to the power of n plus 1, okay, over n plus 1, then we have p raised to the power of n plus 1 divided by q parenthesis n plus 1, q parenthesis n plus 1. So what I will do now is so in this case, q will cancel q, okay? So then we have the maximum speed to be, this will be p raised to the power of, okay, p minus p, that will be 0, because we have q times p over q. Q will cancel q. So we have p minus p in this case. Let me write it out. So we have negative 1 over q, then p minus p raised to the power of n plus 1 over n plus 1, then plus p raised to the power of n plus 1 divided by q parenthesis n plus 1. So this is 0. Okay, this is 0. So which means 0 raised to the power of anything will be what? 0. So this will be 0, so that the maximum speed will be, this will be 0 plus p raised to the power of n plus 1 over q parenthesis n plus 1. Then the maximum speed will be equals to p raised to the power of n plus 1 over q parenthesis n plus 1. So this is the expression for the maximum speed in terms of p, q, and n. The noblest pleasure is the joy of understanding. Bye-bye.